The farthest dark in the universe sometimes behaves like a lighthouse built inside a grave. Astronomers did not expect rhythm out there. They expected a flash, a shrug, and then silence. Stay with me because these signals are not just strange, they keep coming back on schedules nobody can explain. And before we go deeper, subscribe if you want true space stories like this arriving in your feed before they turn old and dusty. Most people imagine deep space as a frozen black room where nothing happens unless a star explodes. But some of the weirdest things we have found are not giant explosions at all. They are taps in the dark, tiny and brief, more like a spoon on a glass than a bomb in the sky. And the unsettling part is not their strength alone, but their rhythm. A repeating signal changes the feeling of the whole story. One burst can be an accident, a bad cable, a dying star, a one-time cosmic crash. 5 different repeaters start to feel like a pattern hiding inside the universe. Not a message, maybe, but something worse for scientists: behavior. Because behavior means there is a system behind it. Something survives the burst, waits, and then does it again. That is like hearing a smoke alarm in an empty house, returning the next night and hearing it again. Now you are not dealing with noise anymore. You are dealing with a machine you do not understand. For years, some of these signals were treated like junk: a glitch, a hiccup, a dirty instrument, a cosmic prank on tired astronomers. That is the underdog part of this story that makes it sting. The universe was whispering, and we kept blaming the microphone. Then the whispers turned into a countable set of returns. Not one odd burst, but another and another and another. By the time researchers started lining up the dates, the puzzle stopped looking small. It started looking like a clock face half buried in sand. To understand this, we first need to go back a long way. A lot of people think every weird radio signal from space must be aliens, but that idea is usually wrong. Most strange signals end up being natural, and that is exactly why these are so powerful. Nature keeps inventing things that feel smarter than our first guesses. Another common mistake is thinking scientists are confused because they heard a voice or a code. That is not what this is. These are bursts of energy, often radio waves, sometimes paired with X-rays, more like flashes than language. The mystery is not what they say, but why they happen again and again. Back in the late 2000s, fast radio bursts were the new scare in astronomy. They were tiny flashes of radio energy, often shorter than a blink. Imagine your kitchen light flicking on for 1,000th of a second and still being seen across a city. That is the feeling these bursts gave researchers. The first surprise was that many scientists did not even trust the earliest fast radio bursts. They worried the signals might be coming from Earth, not deep space. That was a fair guess because telescopes pick up all kinds of human noise. A microwave oven, a satellite, or a bad wire can fool you fast. But the bursts kept showing the same strange sweep in frequency. That sweep matched what happens when radio waves cross huge amounts of matter in space. In simple terms, lower notes arrived a little later, like runners slowed by mud. That pattern suggested the signals had traveled far beyond our galaxy. Then came the first of our 5 repeaters, FRB 121102. At first it looked like the others, a quick burst and then a question mark. Scientists expected a one-time disaster, maybe a star collapsing, maybe something that destroys itself. That was the safe story, neat and final. What they actually found broke that neat story in half. In a paper published in Nature on March 2, 2016, L.G. Spittler and colleagues reported that FRB 121102 repeated. The source did not die after the first burst. It was more like finding out the house fire alarm goes off every few nights, but the house is still standing. That mattered more than it sounds. A burst that repeats means at least some fast radio burst sources survive their own violence. Models based on one-and-done catastrophes suddenly looked too simple. The cosmic corpse had sat up in bed and knocked again. The institutions behind that discovery tell you how seriously this was taken. The team included researchers from the Max Planck Institute for Radio Astronomy, McGill University, Astron, Cornell, and Arecibo Observatory. Names like P. Scholes and J.W.T. Hessels became tied to the signal that refused to stay dead. A glitch does not survive that level of checking. Scientists expected a final scream from a doomed object. Instead, they found a source that could keep throwing bursts without destroying itself. Compressed into everyday life, it was like expecting a light bulb to explode once, then watching it blink back on next week. The first repeater did not answer the mystery, it made the mystery deeper. And once you know one repeater exists, you start wondering how many others are hiding. That changed how telescopes listened. Researchers stopped treating every flash like a random firework and started looking for return visits. The dark was no longer a one-night event. The second finding changed everything again, because it brought timing into the picture. Not just repeating, but repeating on a cycle. That is a much colder kind of weird. A repeating burst can feel wild, a scheduled burst feels organized. The source was FRB 180916.J0158+65. It had first been noticed in 2018, but the real shock came later. Scientists expected messy behavior, the kind of random fit you see in storms. What they found looked more like a calendar. In 2020, a Nature paper from the CHIME/FRB collaboration reported a 16.35-day activity cycle. The corresponding author was D.Z. Lee, and the collaboration stretched across places like the University of British Columbia, McGill, MIT, Astron, and the Max Planck Institute. One of the most useful numbers was brutally simple: 16.35 days. That is not a vague sometimes. That is your wall calendar with a circle around the date. Search summaries about the source described it as being in a galaxy about 470 million light-years away, and yet its timing could feel as familiar as a washing machine that rattles every few weeks. For about 4 days in each cycle, the source became active and could spit out bursts every hour or two. Then it went quiet again, like a porch light on a timer in a house nobody owns. Scientists expected cosmic chaos. They actually found a rhythm so clean that people started thinking about orbits, spin, and hidden companions. Maybe a magnetized star was wobbling. Maybe something was circling something else, opening and closing a narrow window like blinds in a bedroom. This is where the body of the story starts to hum. You can almost feel the cold patience of the source. 16.35 days is long enough to forget, then suddenly remember. It is the emotional shape of a sink drip that stops just long enough to make you think it is over. And that shift from random to periodic changed the rules again. Now the universe was not only repeating, it was keeping time. Would you leave a comment and tell me which feels stranger to you, one impossible burst or a burst that returns on schedule? Your comment helps me see which kind of mystery you want me to chase next. The third discovery did not just repeat, it misbehaved in layers. This source, FRB 20201124A, was not satisfied with being a simple cosmic flash. It started acting like a whole weather system wrapped around a heartbeat. During an active stretch, researchers detected 1,863 bursts in 82 hours over 54 days. That is not a trickle. That is a storm of events packed into less than 2 months. Imagine standing in your kitchen while the refrigerator clicks on nearly 2,000 times, each click carrying a clue. Scientists expected the environment around the source to look fairly steady. Instead, the signal showed irregular short-time changes in something called the Faraday rotation measure. That sounds technical, but it means the bursts were passing through a changing magnetic environment. The space around the source seemed to be moving, twisting, or breathing. For the first 36 days, that magnetic sign kept shifting. Then it settled down and became constant. That is like finding muddy footprints all over the floor every morning, and then one day the trail stops mid-story. Whatever was happening near the source was not simple background noise. And there was more. Researchers detected circular polarization in more than half the bursts. One burst reached 75% circular polarization. That means the radio waves were not just flashing, they were corkscrewing through space in a strongly organized way. In everyday terms, scientists expected a clean whistle. They found a whistle coming through spinning glass, fog, and moving fans. The signal was shaped by its surroundings so strongly that the surroundings became part of the mystery. The room around the alarm turned out to be as important as the alarm itself. A Caltech library record for the paper lists the publication date as September 22, 2022, and points to Nature. The author list includes H. Xu, J.R. Niu, B. Zhang, A.V. Filipenko, D.Z. Lee, and many others. Those names matter because this was not a single late-night claim. It was a major team standing behind a very messy result. The paper described a complicated, dynamically evolving, magnetized immediate environment within about 1 astronomical unit of the source. An astronomical unit is the Earth-Sun distance, so the weirdness was happening in a space roughly the size of our own solar gap to the Sun. That is cosmic in scale, yet small enough to picture as one zone around a hidden engine. Scientists expected the burst to reveal the source itself. What they actually revealed was a whole neighborhood of trouble. It was like trying to hear a doorbell and discovering the whole hallway is full of mirrors, steam, and spinning fans. The signal got out, but not cleanly. This is one reason the repeating burst story keeps refusing to settle. Each new repeater solves one piece and breaks 2 more. FRB 121102 told us some sources survive. FRB 180916 told us some sources keep time. FRB 20201124A added a new insult. It suggested that some repeaters live in local environments so active that the signal gets rewritten on the way out. Not erased, not faked, rewritten, like a note passed through wet hands. And when you stack those three cases together, the category starts to split. Maybe all repeaters are not the same kind of object. Maybe we are using one label for several machines. That happens in science more than people realize. Think of how a kitchen drawer can hold 5 tools that all cut. A knife, scissors, a pizza wheel, a peeler, a box cutter. From far away, they are all just sharp things. Up close, each one is built for a different job. The same may be true here. Some repeating signals may come from magnetars, neutron stars with insanely strong magnetic fields. Some may be shaped by binary partners, where two objects dance around each other. Some may belong to a class we still do not have a good name for. And scientists will tell you they do not fully understand this yet. That is not weakness, that is calibration. The models had predicted something simpler than what the sky is doing. By now, the story had already escaped the idea of a single explanation. If this part of the journey is changing how you hear the universe, would you like the video and tell me why that matters to you? That like tells YouTube this story has value for viewers who are genuinely curious. The next two signals make the mystery even less comfortable. The fourth signal came from much closer than the fast radio bursts, but it felt stranger in a different way. Its name is GPM J1839-10, and unlike the millisecond snaps of many FRBs, this object took its time. It pulsed every 22 minutes. That number alone should bother you. Pulsars, the famous cosmic lighthouses, can pulse many times each second. Scientists expected anything throwing radio beams like this to spin fast. What they found was an object moving far too slowly for the standard story. CNN's report on the discovery said Curtin University doctoral student Tyrone O'Doherty first spotted the unfamiliar object in March 2018. Later, a team led by Dr. Natasha Hurley-Walker at the Curtin University node of ICRAR went hunting for similar objects. Between July and September 2022, they watched the sky with the Murchison Wide Field Array in Western Australia. And there it was, tapping back every 22 minutes. The object sits about 15,000 light-years from Earth in the constellation Scutum. Each burst lasted up to 5 minutes. Not a blink, not a spark. More like an oven timer that glows and hums while the room stays dark. Scientists expected either a neutron star or a white dwarf with a strong magnetic field. Those were the familiar boxes on the shelf. But Hurley-Walker said the object was spinning way too slowly to produce radio waves. In their language, it sat below the death line, where emission should fade out. That phrase, death line, sounds dramatic because it is. It means the object should not have the energy set up needed to make the radio pulses we are seeing. Expected result? Silence. Actual result, a 5-minute radio pulse every 22 minutes for at least decades. And decades is not an exaggeration. The team checked older archives and found the object had shown up in observations from the Very Large Array dating as far back as 1988. Hurley-Walker said she was 5 years old when telescopes first recorded pulses from it. The signal had been sitting in old data like a receipt left in a cookbook. That may be my favorite detail in this whole story, not because it is romantic, but because it is brutal. The universe can be shouting at us through the data for 33 years and we still might miss it. Not because it is faint, but because it does not fit the drawer labels. Scientists expected a dead object acting dead. They actually found a source that kept pulsing for at least 33 years. That is like opening a storage closet and hearing a metronome still ticking from a box nobody touched since the 1980s. The fear in that image is not loud, it is patient. Hurley-Walker called it a remarkable object that challenges our understanding of neutron stars and magnetars. Follow-up work used the Meerkat radio telescope and ESA's XMM Newton space telescope. That matters because different instruments check different parts of the story. The signal survived the change in witnesses. And this is where the emotional scale swings hard. 15,000 light-years is so far that human history disappears into dust. Yet the pulse length, 5 minutes, is the time it takes to boil water, burn toast, or wait for a text reply. The cosmos keeps dropping world-sized facts into kitchen-sized time. Scientists expected a quick fit into known physics. Instead, the object raised the possibility that long-period radio transients are a category we barely understand. Maybe they are weird magnetars. Maybe they are stranger than that. The fifth and newest signal pushed the case into another corner. It is called ASKAP J1832-0911. And what made it different was not just that it repeated in radio waves and in X-rays. A 2025 page from NASA's Chandra X-ray Observatory says ASKAP J1832 cycles in radio intensity every 44 minutes. Using Chandra, researchers found that it also varied in X-rays every 44 minutes. That was the first time such an X-ray signal had been found in a long-period radio transient. One rhythm, two kinds of light. Scientists expected maybe a radio oddball. They actually found a source whose radio and X-ray changes lined up like two clocks chiming together. If GPM J1839-10 felt like hearing footsteps in the attic, ASKAP J1832 felt like hearing the footsteps and seeing the ceiling lamp swing at the same time. Two systems agreeing makes a mystery heavier. The Chandra page says the object is about 15,000 light-years away. It also says it changed dramatically in both X-rays and radio waves over 6 months. That means the source was not only pulsing on a 44-minute cycle, it was also changing its overall mood across seasons, like a heater that clicks on every hour but grows weaker each week. The release date for that Chandra page was May 28, 2025. It credits X-ray data to NASA's Chandra X-ray Observatory and names Ziteng Wang of Curtin University and collaborators. The page says the work appears in Nature, and it lists exact observation dates from February 14, 2024 to August 11, 2024. Even tiny exact numbers start to matter here. The page notes a total observation time of 8 hours and 9 minutes. That sounds small beside cosmic distances, but in signal hunting, 8 hours and 9 minutes can be enough to catch a rhythm that rewrites a category. A short listen can expose a very long lie. Researchers argued that ASKAP J1832 is unlikely to be a normal pulsar. A neutron star pulling material from a companion also did not fit well. Some features could match an old magnetar, older than 500,000 years. Other features did not fit that idea either, especially the bright, changeable radio emission. Another possibility involved a white dwarf with a companion star, but the Chandra page says that would require the strongest magnetic field ever known for a white dwarf in our galaxy. Expected answer: one known object class with a familiar engine. Actual answer: every explanation seems to fix one problem and create another. That is the point where this stops being a list of odd cases and starts becoming a challenge to the map itself. We like the universe best when every object has a drawer, and every drawer has a label. Star, planet, pulsar, white dwarf, black hole. But these 5 signals keep sliding halfway out of one drawer and halfway into another, like a utensil in the kitchen that looks like a spoon until you try to cut with it. One shared idea keeps showing up anyway. In all 5 cases, scientists expected something simple enough to name quickly. In all 5 cases, the sky answered with a source that either survived, repeated, kept time, changed its local environment, or glowed in more than one kind of light. That does not mean the signals all come from the same engine. It means the universe may have more than one way to build a repeating beacon. A magnetar is still one of the strongest suspects in several of these stories. That is a type of neutron star with a magnetic field so strong it can twist space around it with violence we can barely picture. If Earth had anything even remotely like that in the kitchen, your fridge magnets would not fall off. Your whole kitchen would stop being a kitchen. The problem is that magnetars explain a lot, but not everything, and that is where the trouble begins. Scientists expected magnetars to help because magnetars are already extreme. They flare, they quake, they throw out energy, but what they actually found in these repeaters was often more organized than a simple tantrum. Some signals came back on schedules. Some lasted much longer than expected. Some seemed to pass through local magnetic weather so tangled that the signal looked bent, spun, and polished on the way out, like light through a warped bottle. That leaves room for orbiting systems. Maybe in some cases a neutron star is circling another star, and the bursts only reach us when the geometry lines up just right. Think of a porch light seen through fence slats. Most of the time the slats block it. Then, for a few moments, the angle shifts and the light flashes through. That kind of picture can help explain a cycle like 16.35 days without forcing the source itself to turn on and off like a lamp. But even that idea does not solve every case. A clean orbital clock might help with FRB 180916. It does much less for a source like GPM J1839-10, which kept pulsing on impossible terms for decades. And it does not fully explain ASKAP J1832, where radio waves and X-rays rose and fell together every 44 minutes, while the whole source also changed across months. One explanation starts to feel like one house key being pushed against 5 very different locks. This is where good science gets less cinematic and more honest. Scientists do not get points for forcing the answer too early. They get points for refusing to pretend the answer is cleaner than it is. That is why the most trustworthy part of this whole story may be the hesitation. The teams behind these papers are not saying, "We solved it." They are saying, "Here is exactly what the sky did, and our best models still leave bruises." That matters because mystery is not the same as ignorance. Ignorance is having no clue. Mystery, in science, is having clues that point in different directions at once. The pulse periods matter. The changing polarization matters. The old archive detections matter. The X-rays matter. Each one is like hearing a different floorboard creak in a dark house. You do not know who is upstairs yet, but you know the house is occupied by something real. There is also a quieter lesson hiding underneath the astronomy. These signals remind us how much discovery depends on what we are willing to notice. GPM J1839-10 was already in older data. That means the universe did not suddenly become weird. It was weird the whole time. We just did not have the habit of looking for a 5-minute pulse every 22 minutes from an object that should have been silent. Sometimes discovery is not opening a new door. It is finally turning on the light in a room you already own. That is why repeating signals feel so haunting. A one-time event can still belong to chance. A repeating event feels like intent, even when it is natural. Not message-level intent, not aliens tapping Morse code. More like mechanical intent, the kind you feel when the same floorboard snaps under your foot every time you cross the hallway. Pattern creates personality, and personality is hard for the human brain to ignore. If this is the point where the story stopped feeling like trivia and started feeling personal, would you leave a comment and tell me which of these 5 signals would keep you awake the longest? Commenting helps me understand which kinds of deep space mysteries you want me to follow next, and the answer might say something about what kind of unknown bothers you most: chaos, clocks, or silence that should not be breaking at all. There is another reason these 5 cases matter. They train scientists to build better questions. For years, a lot of astronomy was shaped by what instruments were good at catching: short flashes, bright events, easy categories. But the universe does not care what is convenient for us to detect. It can whisper on a 44-minute cycle, hide inside old data from 1988, or spend weeks changing the magnetic fingerprint around a burst source before calming down again like nothing happened. That means the next breakthrough may not come from one giant explosion. It may come from patience, more archive searches, more wide-field radio surveys, more instruments watching the same object in radio waves, X-rays, and anything else we can bring to bear. In the same way a home mechanic learns more by listening to the engine, smelling the exhaust, and feeling the vibration together, astronomers now need every sense they can borrow from their machines. And there is a deeper emotional twist here. We are used to thinking of deep space as distant, cold, and mostly removed from ordinary human time. But these signals drag the cosmos into the rhythm of daily life. 22 minutes, 44 minutes, 4 active days in a 16.35-day cycle. 8 hours and 9 minutes of observation. Those numbers feel strangely domestic. They fit on a timer, a calendar, a stove clock, a sticky note on a fridge door. That is what makes the story stick. Billions of miles and millions of years are too large to feel in the body. But a pulse every 44 minutes is something your body understands. You can feel 44 minutes while waiting for a bus, sitting in class, driving home, or lying awake at night. The universe becomes less like wallpaper and more like a breathing thing in the next room. Not because it moved closer, but because it started keeping time in units we live inside. At the start, the dark felt like a grave with a lighthouse hidden inside it. Now the image changes. It is not just a beam in a grave, it is a house at the edge of a black sea, and every so often one room lights up, then another, then the whole place goes still again. We used to think the light meant the house was burning down. Now we know something inside may still be walking from room to room. That is the flip that matters. We began with the idea of death speaking once. We end with the harder idea of survival speaking many times. Some of these sources may be wounded stars, ancient magnetic wrecks, or systems trapped in dances we do not yet understand. But whatever they are not simple endings. They are ongoing behaviors. And behavior means the universe is still doing things behind the curtain that our best names cannot hold. So when the next strange pulse appears in a radio dish, or in an old archive, or in some line of data a student almost skips past, remember this. The scariest possibility is not that deep space is empty. It is that deep space is active in ways that are patient, repeatable, and only partly visible to us. Somewhere out there, right now, something may already be counting, turning, flashing, and waiting for us to notice it again. And maybe that is the feeling to carry with you after this ends. Not fear exactly, not comfort either, just the quiet conviction that the universe is not asleep when it looks dark. It is busy in hidden rhythms, tapping at the walls of our understanding, one impossible signal at a time.